All right, so warm welcome to the third session of the PHP track. And quick question up front. So who stayed in the room from the last talk? So how many people do we have still in the room? Okay, looks like a third maybe. That's cool. Okay, so this session, the speaker of this session is Stefan Priebsch. He is, I hope I pronounced that correctly. Correct me if I'm wrong. Stefan is a software consultant, developer, and author of several textbooks, and he's also co-founder of the PHP CC. And he's going to talk about the topic of domain-specific languages with PHP. So, give it up for Stefan.
Good morning. Good morning. Good morning. How's everybody doing today? So I'm gonna take you on a journey, and the in-flight movie is titled Domain-Specific Languages in PHP or with PHP. The PHP is not really very important today. I think a lot of what I have to say is pretty much language agnostic. You might see some bits of PHP code, but don't worry. Maybe it's a kind of a surprise movie. Let's call it a sneak preview. It's the first time I give this presentation. I'm very eager to share some of my thoughts. Some of those thoughts may be a little unfinished, and I'm very eager to discuss with you after my presentation what you think and where we agree and where we maybe disagree. So as already has been mentioned, I'm a consultant. We help companies develop software successfully. I'm also a coach working with teams, basically I get in the company and tell the teams that their code is bad, and they really love me for doing that. I'm also a university lecturer. A couple of years I started giving lectures on web development at the University of Rosenheim, and I'm a world famous scalability expert because I'm the father of twins. So what are domain-specific languages? Well, a domain-specific, what you always do, you look it up on Wikipedia, right? Thank God Wikipedia is built in PHP. So a domain-specific language is a language that is specialized for a certain application domain. And the opposite of that is a general-purpose language. Okay, well, that's, we have some noises there. Can we get rid of them? It's the other microphone. Thank you. Okay. Some examples. HTML. Well, you may have heard of that one. It's a domain-specific language for hypertext documents. Cascading style sheets. That's the presentation of those documents. It's also a domain-specific language. JavaScript is not a domain-specific language because we have JavaScript on the client, we have it on the server, we have it everywhere, it's cool, and it also does your dishes. So it's certainly not a domain-specific language, it's a general-purpose language. Java is sometimes being referred to as a domain-specific language to convert XML files to stack traces. Other domain-specific languages that you may or may not have heard of is SQL, Awk, GraphViz, Make, and all those build tools. The XUnit, which is a kind of language tailored to testing, Gherkin, Cucumber, all the other implementations that there are for the BDD style stuff. And there is lots more. Regular expressions are a domain-specific language in itself, for example. And technically, there are two different ways of building a DSL, a so-called internal DSL and the so-called external DSL. Now, the external DSL is you're building your own language. So you're using the usual tools to build a compiler, you come up with the grammar, do everything, and it seems to be quite common these days to build your own language. So I would advise strongly against doing that. You don't really want to build your own programming language, and you don't want to come up with all the tooling and live in the void of nothing. Instead, I would always recommend looking at an internal DSL, and the way I look at DSLs, as it's going to turn out throughout the presentation, is a little special in itself anyway. So always go for an internal DSL, which basically means use an existing general purpose programming language, for example, PHP, or anything other, but not JavaScript. I'm joking. I'm joking. Okay, we'll get to that. We'll get to that. And build your own domain-specific language on top of that or inside it. Now, one of the big advantages of that is whenever there is something that your domain-specific language does not cover, you can use the general purpose language directly to just build that. And with an external DSL, anything it's supported, you can do. If it's not supported, you have to build it first. And trust me, with my own business, we at some point were in the situation, well, we are software consultants. We know how to write software, right? So we're going to write our own invoicing software. And of course, we're going to make all those use cases explicit and do it the really kick-ass version. And what we ended up was a software that would cover all the business cases that we knew to that point. And anything new that happened, our software couldn't handle. So, and I'm not making this up. It's at one day, somebody transferred 30 euros for flowers to our account, which of course was a wrong booking, but our software couldn't handle that, which basically brought our own software to a halt. And we had to fix the software to make these cases work, which is kind of quirky. So again, don't use DSLs or anything similar to limit yourself to just make a certain amount of things possible. You will sooner or later have to address other things. Now, Perl, believe it or not, Perl, this is for real, originally was a domain-specific language. It was created as a domain-specific language, as you can clearly tell by the meaning of the acronym. And I didn't make that up, it's on the internet. It's a domain-specific language for text extraction. I like to call it a write-only language. Essentially, I've tried to learn Perl a couple of years back. Who knows Perl? Congratulations, you're all more smarter than I am. I tried to learn Perl and I was unable to read the code. I was able to write some code, but I didn't really understand the code, which led me to the conclusion that Perl is the only programming language that looks the same before and after RSA encryption. So let's talk about code. This is Hello World in a rather seldomly used programming language called whitespace. And this is, okay, let's turn on syntax highlighting. This is Hello World with syntax highlighting in whitespace. If you think this is easy, try brainfuck. Okay, no, those are, I guess those are languages that somebody came up with because they could. They had some time to spare. Probably they had no kittens, so they had to create programming languages. Let's look at a serious programming language. This is a valid and allegedly working, I have to admit I haven't tried it, C program that calculates pi. By going through that circle and taking the space and then calculating pi. And you can increase the accuracy by creating a bigger ASCII art circle. When I started as a developer, the first company I worked with, we were writing C code back then. Actually, we were implementing a JVM on a chip card, which was bleeding edge kick-ass technology at the time. And a senior developer said, well, the thing I find so intriguing about C is if you have 3 developers, you show them a short C program, and you ask them what it does, you're going to get 3 different explanations. So what is code? I tried to come up with where the, I researched where the word comes from, and what I could find was that code seems to originate from the Latin word codex, which originally meant a piece of wood. A piece of wood is something you can write on if you don't have paper yet, okay? So later, that term, the meaning of the term changed, and it became, in Old French, the meaning was a system of law. Now that's very interesting. System of law. Do we have any lawyers in the room? Okay, so nobody's going to sue me, but they are taping it, so let's see what happens. So this is a quote. It's not a literal quote. Years ago, I've read that in a column written by Roman Herzog, who's a former German president and also former president of the highest court we have in Germany. And he said, and again, it's not literally, but well, it at least conveys the meaning. Laws must be easy to understand. Otherwise, we cannot expect people to respect the laws. That's kind of interesting. So, have you ever written law? Maybe you have a basic law in Germany. That's pretty easy to understand, I think. But maybe, well, try something obscure, like the laws about importing, or laws about traveling to North Vietnam with a kitten. I don't know if that exists. So regular people don't understand laws. Now, we have a lawyer, and whenever we speak to our lawyer, basically the message is, well, this is my interpretation of what I think it means. Well, the courts may have a different interpretation. You never know what the judge is going to rule. So law is kind of weird because it's not concise. Well, later again, the meaning of the word still changed, and it started to also mean cipher, which is a message hidden, concealed. So that's cryptography, hiding messages, secret messages, messages that you're not supposed to understand. And then, quite lately, code also started to mean instructions for a computer. Now, should a computer program be cryptic, concealed, hard to read? I think not. So why do we name it code in the first place? This is a quote by Martin Fowler, Kent Beck, and others. It's part of their refactoring book. And they're saying, well, any fool can write code that computers can understand, but it's really hard and challenging to write code that humans can understand. Well, we're writing code to communicate with other human beings, believe it or not. We are writing code for our fellow developers and maybe even the business to read the code and understand what it's supposed to do. The fact that the computer executes the code is a mere coincidence. The real reason, and I think that's my opinion at least, the real reason why we write code is because we are writing down in a formalized way our business rules. And we want to write them down in a way so that other developers can understand them when they read them later. Always write code in a way that you think that whoever reads it after you is a psychopath who knows where you live. I think that's a quote, something like that, that I've written on, that I've read on the internet. So it's a computer program, it's not code. I think the term we're using is wrong because it's not a secret society of programmers. It's not a secret art that only the geeks can master. It's a commodity. Software is everywhere. You are probably working in a software company, whether your company has already realized or not. All companies nowadays are pretty much software companies. Whenever you do something e-business-like or something or something quick and something flexible and something at scale, there's always loads of software involved. So everybody works in a software company. We have a terminology problem. And we also have a terminology problem, not only on the technical side, but also on the business side. If you want to have some fun, get popcorn and gather everybody together in your company and say, okay, so what's a customer? I have one client where I years ago asked the question, so what's a product? And they were unable to answer that. Now, this is not a joke, it's real. And there's actually a very, very valid reason behind that, because for that very business, product is something that's very, very complex, because it's not something off the shelf. So it's not even easy to define a term that everybody thinks is ubiquitous. People tend to call users of their website a customer. Well, I think somebody is a customer. I personally think somebody is a customer if I have some money that they've paid for services that we've provided. Technically, I would probably also consider them a customer if we render services and they don't pay. But the interesting question is, when does somebody turn into a customer? Go ahead and ask this question in your business. You're going to get very different answers. And since nobody can agree on the terms, and the terms are unclear, how can we write decent software? Well, it turns out we can't. We need to get clear on the terms, so let's create a glossary. Who has a glossary of important business terms? It's not too many. And it's hard to create one. Basically, with every client I work, sooner or later I say, okay, so where is your glossary? And then we get to the point of, well, maybe we should create one. And then everything goes downhill because it turns out not to be easy, because nobody can agree on the terms. This is where bounded contexts, domain-driven design concepts comes in very handy. So, assuming we have a glossary, and we have the terms, and we are clear on the meaning of the terms, now we start writing software. Those are terms, well, we agreed it's not code, so it's a computer program, right? So the question now is, do the terms that we use in the glossary match the terms that we use in the program? Well, glossary usually contains these terms. Well, that's just an example. For your business, they're probably going to be a little different. Other things may be important. Some of those may be not important, but invoices technically are important to every business. So it's pretty safe to have that, and customers as well, orders, well, whatever. When I look at the software, those are the terms that I see. Controllers, views, models, managers, builders, resolvers, providers, some technology crap that I don't even understand, services, whatever. Doesn't seem to match up. This is the most important lesson that every developer needs to take home. We do not have to make the world adjust to technology. We need to make technology adjust to the people, which in your business means you have to speak a common language, and this common language has to be the language of the business. You can't force them to use technical terms because they don't really understand all those technical terms. How often has your business asked you to create another database table? What the fuck do you know about database tables? That's none of your business. That's an implementation detail. So, at some point, we'll start documenting requirements. Very traditional way would be to create a 150-page document. Maybe that's a little outdated. Maybe we'll just draw some boxes and arrows. Maybe we're agile, so let's just create Jira tickets. So the problem here, let's assume we are able to come up with a solution. Now you have software, and you have requirements. Do they match up? How do we know they match up? Well, usually we don't, because you can't match up software to a Word document. At least I don't know how to do this. Actually, some developer recently suggested it's XML, and we could technically parse XML. It's a documented format, so we might be able... You get the idea. We have a gap between program and documentation, and we need to find a way of closing that gap. Now, it's a commonly accepted best practice to create API documentation right from the code. That's the only sane way of doing that, because it ensures that your API documentation is in sync with the code. But that's just the API. It basically says, well, this is what you pass in, this is what you get out. It doesn't really say what it does. So the behavior needs to be documented through tests. That's the only way. And if tests document the behavior, we are on the track to something valuable, I think. Behavior-driven development is one approach that basically suggests, well, let's refrain from the Word document, let's break it down, let's create a natural language description in the terms of the business, and let's turn those into executable tests. I think it's a brilliant idea, but I kind of hate the way they're doing that, because have you ever looked behind the scenes? What they do is they have regular expressions that kind of break those sentences down and map them to executable code. And I don't trust them. And they only work if you stick to the language that the regular expressions understand and supports. And I've seen teams trying to get into BDD, and at some point they started creating a UI where business would click together those descriptions, because by clicking together them, they would make sure that the wording is exact and that the tests would actually work out. I think, personally, it's not the best idea to kind of force the business to write the tests. I mean, that's behind this idea. And then BDD looks at the wrong end of the stick. BDD makes the tests readable, which is great. But it doesn't worry about, is the production code readable? Or is the computer program readable, as we hopefully have agreed to name it by now? So it's kind of missing the important part. But tests as an executable specification is a great idea. This is something that Sebastian Bergmann and I came up with a while ago. He has that neat feature in PHP unit called test docs, which does nothing but explode the method name of a test and do the case magic, and then you get readable sentences. And I love to use that as a grounds of discussion between a development team and the PO when they write up their requirements and say what they need. Then this is what the team should respond with. In that example, it's kind of an insurance contract, and you can really look at that and say, oh, it runs for 12 months, okay. Cannot be cancelled more than 3 months prior to expiration. Cannot be cancelled less than 3 whatever, yes. Can be renewed at any time. Cannot be downgraded to a standard contract. Well, I know what it does. And you know what? By executing that, I get those check marks that are going to tell me, and this actually works. It's kind of similar to the ideas of behavior-driven development, but less magic, less technology behind the scenes. So essentially, there are various ways of achieving that on the test side. Now let's look at the production code or production computer program side. Domain-driven design is unfortunately a hype these days. I think it deserves to be a hype, but still it's a hype. Well, I'm part of the hype, so what? Use DDD patterns as building blocks. The 4 important patterns that DDD gives us. So who's doing DDD, by the way? Oh, not too many. Who's interested in doing DDD? Okay, I like that. Who hates DDD? For what reason?
Mostly find it's difficult to get people away from they get too technical.
Okay, because people are too technical. Yeah, that's a good point. So we have 4 important patterns. An entity, which is not an entity in ORM sense, it's a business object. It has an identity. A typical example would be an invoice, which has a given invoice number, and there is only one invoice by that number. And you cannot have another invoice being the same thing and stuff like that. A value object, which technically is immutable and is the smallest building block in your vocabulary, it's a business concept encapsulated in an object. So it's a self-validating thing because objects are not allowed to be in an invalid state. And it's kind of Lego bricks that you can start building your business on. You have an aggregate, which is a cluster of domain objects. I love that concept because it's a working set. It clearly defines this is the bunch of objects that I need to work a certain use case. And I will not have to deal with eager loading and lazy loading in my ORM. That's the working set. And I have to clearly define that working set up front. That's why I love aggregates. And we have services, which is stateless business logic that wouldn't really fit into any of the other categories. A very good example for that would be an invoice number generator. So German law requires invoice numbers to be a sequence and without gaps, because otherwise you could just not report certain invoices with the tax authorities, which they really don't like. So that's a very good example for a service. That's something that by some weird or less weird technology manages to give us a sequence of invoice numbers. Now, ubiquitous language, and this is a kind of a very, very small PHP example just to give you an idea. If you use these building blocks, that's an order which is an entity, and those order IDs, payments, print data, that's value objects. And this is kind of an artificial example, similar to stuff that one of my clients does. I really can't show client code, so I'm always coming up with some stuff that looks similar. And this is, we're receiving payments, and we're receiving print data, and when we have received both, we need to get printing started. So that's actually just the code that does that, and should production begin, if we have a payment and print data, then we will begin production. Okay, I think that's actually pretty readable code. This is what you get if you take a shot at domain-driven design and really manage to keep all the technology out. This will work well if you do not attempt to create one big model. You need to create many small models. That's on some slide that's going to come up, I think. One way of getting there is playing nouns and verbs. The nouns are likely to become classes. The verbs are likely to become methods. So having a plain text description of what you're about to do, marking the nouns, making them classes, making them your small Lego bricks of business language, and then building up on them. And verbs tend to become methods. It doesn't always work that way. Usually you tend to have more classes than you initially thought. But then once you look at the whole thing and say, well, you know what? You have those classes there. They are so obvious. Why the hell did it take you so long to get there? It actually can take quite a while to really get to the right abstraction and to really figure out for your business, what is a product? What is a customer? What needs to go in there? In which contexts? What does it need to be? That's what domain-driven design is all about. And it gives you that ubiquitous language, one of the most important concepts they have in domain-driven design. That's the common language between business and development. And you want to reflect this common language in an executable specification and in readable code. Then you don't need any further documentation that's decoupled from the code, and where nobody can ever tell, well, we have code there, we have a documentation there, we don't really know if they match. And honestly, they never match. Maybe they match on day one, but after 2 months of refactoring or adding new features, pfft. So, let's summarize. Use your favorite programming language, unless it's something else than PHP. That was a joke again. Give me at least some noise for the camera up there. Okay, thank you. Use your favorite programming language. Don't create an external DSL. Do not create your own programming languages. There are many of them, and I think there are enough, right? Unless, I think people who create programming languages, they don't have kittens. Maybe we should buy them kittens. I think there are too many programming languages. don't have your team build a programming language just so that you're able to build a DSL on top of that, right? I think it's too much of effort. Build an internal DSL based on your ubiquitous language. It's technically nothing special. It's just a term. And the whole concepts of domain-driven design and of sane software development and let's really create tests and not just talk about them, they come together and they will have you end up with software that you actually like. And software that business people will be able to understand. Not the technical parts, not the infrastructure parts, but the business rules. You want them to be expressed as clearly as possible, and you want to be able, on your production code, to sit down with your PO or your domain expert and say, look, this is what it does. Do you agree? You don't have to understand any technical terms. This is just the business rules there. Do you agree that this is what we need? It's actually very hard to achieve that level of abstraction mentally with everybody involved to get there. But I can assure you, you should give it a try, because once you get there, your world is going to be a little better at least. Then, I already mentioned that, do not build one big model. You're going to fail. Because people have different requirements in different contexts. They are very, very different things, and if you mash them up in one model, you're always going to have a maintainability issue. Because if you change something, that somebody else is going to be affected. You need to break down your software in small parts so that you do not affect other people. Some people like to call that microservices, but that's another hype I do not want to talk about today. I think there is some value in making things small and self-contained. Whether you want to call it microservices, be my guests, but don't be religious about microservices. And then give up on that last little bit of readability. Think about the 80-20 rule. That last little bit of readability, that would require us to kind of create a configuration file for our business rules. There have been many attempts to do that. BP and ML and BP people and what that stuff is all called, and I don't even remember all those acronyms. And a lot of that has already been retired. And what they try to do basically is, well, let's make programming end-user compatible. Let's have the end users program. Well, they can do macros. Maybe they can do some plugins at the WordPress Drupal level, something like that. But I think end users should not program. I think developers should program. End users should be able to read the code and understand the code. And you should be able to discuss your code with a domain expert. Maybe not an end user, maybe domain expert and end user is the same in your case. It depends. Trying to achieve the perfect, like that's the natural language description, is going to give you a lot of technology overhead to achieve that. I would advise against trying to do that, because there is no real benefit in that. Use your favorite programming language, write readable code, use tests as an executable specification, and please, please, please keep all that technology crap out of your business logic. You're going to find the slides and some more material that I put up at that URL. It's php-craftsmanship.info. I'm going to leave that up for a second. And other than that, thank you for listening. We have time for some questions, and we have a microphone walking around. So if you have any question, feel free to raise your hand, and there's going to be a microphone coming up. Thank you. Yeah.
So first of all, thank you for the interesting presentation. And
You're welcome.
I guess the main idea is to encourage people to write readable code, right?
Yes.
I guess part of that is the comments and doc blogs, and there are a lot of fierce discussions and holy wars on the internet. What is your idea about comments and doc blogs, and what is their role in the code? Thank you.
I make it very, very concise. I like doc blogs that add information, like this piece of code throws a certain exception and is not part of the API in PHP at least. If in your language that information is missing, it makes perfect sense to add that in the doc block. I don't like to add redundant information in the doc block. So as of PHP 7, we have Scala types and return types. I see no point in repeating that in the doc blocks because, well, the code is right by definition. When it comes to commenting, very simple. I don't write comments because if I have to write a comment, the code is not clear. So instead of writing a comment, I'm going to try to express that in code. For example, by creating a method that has a speaking name, rather than writing a comment above a block of code. You should have short blocks of code anyway. There are rare exceptions to that rule. If you have something like, this is a bug in whatever, and this is a workaround for that bug, it's perfectly okay to write that comment. If it's something really weird saying, hey, I know this looks weird, but call me before you touch that, and I've seen those comments. And then the problem is that the person is gone and you don't have their phone number. There are some exceptions, but generally, if your code needs comments, it's the wrong end of the stick. Make the code more readable.
Next question.
Well, that's an interesting example for shortest path algorithm here.
Hi. In the process of designing your domain model and trying to implement that, there has to be some point where you become technical inevitably, because you have to write some low-base logic to make the code do something. When do you think there should be a line for the business to stop there and say, no, go no further, this is the line you don't understand anymore?
That's a very good question, and I think there is a pretty straightforward answer to that. If you look into solid principles, the D in solid is the dependency inversion principle, not dependency injection, as some people tend to misquote it, but dependency inversion. Dependency inversion means invert your dependencies. Do not have your business code, your domain code, depend on infrastructure, aka technology, but have your technology depend on your domain. And it actually works out to do it that way, and it is pretty simple once you get the grasp. It looks deceptively as it would, well, it's nothing special. Essentially, it's create an interface and code against that interface, but you need to create the interface. That's the catch. You are not allowed to use anybody else's interface. You need to be in charge of the interfaces, and then that's the basis for dependency inversion. Now, if you have that, your domain code does not know about infrastructure and has no dependencies to infrastructure. So you can take your domain code, you can give it to business and say, okay, let's just assume that magically we're going to make this happen. And you don't care about the magic, that's something separate. It's technically library, infrastructure, whatever. So there is a very, very clear boundary. You don't really have to worry about that.
Next question.
So then I would have a small question. Surprise, surprise. No, so actually you talked about external domain-specific languages and internal ones. And if I got that right, by internal you're really referring to like being domain-driven by design, by the software design?
No, technically the term refers to build your domain-specific language in an existing programming language. The other thing is build your own language. Build your own interpreter or compiler, whether you compile it down to something executable or cross-compile it to something else. I mean, that has been very en vogue in recent years as well. Think about TypeScript, think about all the other, well, a lot of stuff that's going on at the JVM, right? So it's just the way of implementing that. Technically, there is no direct correlation to domain-driven design concepts. There is a lot of overlap, obviously, because if a domain-specific language, the name language suggests that it's a vocabulary, it's something that should reflect your business, and this is something that we also have in domain-driven design as ubiquitous language. As developers, we tend to start thinking from technology. Oh, let's create a language. Let's build on technology. Let's use tools and technology to build stuff. This is the wrong end to start. You start building your domain-specific language by discussing with business and understanding business concepts and starting to encapsulate small business concepts in those reusable pieces of code. This is where it ties together.
And could you imagine to go one step further and actually like externalize that in some way or form? Because what I usually find is that if there's some way to input things into the system, it's usually done via forms, for example. But in some cases, I find it would feel much easier if I would just have a way to write something that looks like code, but it's like very tied to the domain-specific language that we've built. So I imagine something that would be on top of what we just like learned about, but like just making it easier to input certain thoughts, to try out things faster, but use what you've just described. So is that something that you've like have an opinion at, or?
Well, technically, you may be talking about code generation. On the other hand, you may be still a little too locked into that forms, which is already technology. If you talk about forms as an input mechanism, well, forms is HTML, is HTTP, so you're on the web, and that's technology. Now, of course, your application at some point needs to receive commands, and maybe needs to react to events, and maybe emits events. Well, that's all the domain-driven terminology around there. Whether that originates from a form or not doesn't really matter. But I think there was a second question hidden about the writing something down in code that you mentioned. Can you explain that further?
So what I try to say is that oftentimes I find myself that I can write everything in PHP, but it takes a lot of time. But if I like abstract away concepts, so for example, like parsing certain parts of an HTML document, so that's a very concrete use case that I have, I can extract that away in a function call, so I can just call that function. But I find myself in situations where I need to be very flexible from an end user point of view, and I need to be able to stitch together the certain like extractions that I'm making, and like, so I won't be able to do that on a code level, but I'm like on an interface level. I need to store that in a database somewhere, for example. So I need to stitch together the domain logic in some way or form. And then this is the point where I like often wish to have some sort of language to express that need.
I see your point, and I see the problem, and yes, the problem exists. In my experience, the problem tends to be overrated. Now, when I was at university, one of my teachers said, you know, if a computer scientist is asked to write the same or a similar program the third time, they are usually going to write a program generator. And I think this is the way of thinking that we have there. Well, I would be better off writing a program generator. Now, if you are in a setup where you're literally doing this 100 times each year, I would agree. If you are in a company where you're going to do that 5 times a year, even though I hate saying so, do it manually. Write the code explicitly just as you need. Because as soon as you basically can come up with your language, you need to write a parser for that language, and you lose the ability to test stuff in a small scope. Because now you have an interpreter interpreting the language that does stuff, so there's a lot of technology going on before you can test your simple business cases. And if you've, on the other hand, experienced how easy it can be to write a bunch of small objects and literally test them to death so that you know, well, they are not going to misbehave, it starts getting more and more difficult to build crap on top of sane components from a business perspective. So my personal advice would be stay away from that. Let's create a configuration file. Let's make it flexible in the database for as long as you can. But of course, there's so many businesses that have 500 different types of whatever. You're not going to create 500 classes. Sure. Yeah.
Okay. Thank you.
There's one up there.
I'm not sure if that was a clap or a question.
There was a raised hand, I think.
Yeah, then one more.
Okay.
Thank you. What I thought about is if you go with business logic first and then inverting the logic, first business logic and then technical stuff, there could be a problem that people think about all sorts of stuff that sound really awesome and let's do it, but then you notice that it's just not possible. Like logic, like let's sell tickets to go to Mars, and then you figure out, well, that's technically not possible.
Well,
so how can you tackle this problem?
Let's be a little picky on that. I think that Richard Branson already has sold those tickets. And I can sell tickets, whether there's going to be a flight or not, that's a whole different story. But that's just on the side. Don't we have the exact same problem when it comes to technology? Bringing in all those new toys, all those great fancy technologies, and we can do so many things with that, but can we do what the business needs with it? We don't know. So it's exactly that's a problem that you always have. And of course, on the business side, you can't just go wild asking to implement things that are impossible. That's where the concept of business value comes in. So what's the business value of doing that? Maybe we can earn a shitload of money selling tickets to Mars. Actually, that might be a great idea for our next startup, right? Maybe we can earn a shitload of money, but maybe we also think, well, you know, I wouldn't want to go. I don't want to leave my kids behind. So let's find a different business model. Maybe, how about going to the moon? That's kind of a little more realistic. Or maybe just some space orbit. So by scaling down the wishes and having an open discussion, which basically is something that already should happen or will happen at the business level anyway, you'll have to get that down to a decent level. And then there is Agile. At least everybody claims to be Agile these days. What Agile really means is, let's find a very, very small thing that we can build and that we can get to the market. And then we get feedback from the market. Maybe we even get business out of that. And once we get business, then things usually tend to steer themselves because you suddenly have customers, and customers want things to be done. So you have a completely different set of requirements as compared to the ones you originally discussed. And that's, of course, just the way life is. And I think life is good. If you have people on the board that throw in, that grow the scope to unrealistic sizes, that's a people problem, not a technology problem then. Okay, I think that's a good conclusion. Thanks again. Cheers.